guys, 45 here. We're going to do this with no numbers. I'm just going to show you how to set it up because today is the day before Thanksgiving and we're going to do something fun. Okay, so we have a satellite. It's in a circular orbit, so it's like this. So what do we put? Circular orbit above the Earth. So here's the Earth. This guy right here is the Earth, and let's say it's M1. Here's the satellite, M2. The satellite is in a circular orbit around the Earth. Yeah, it's elliptical technically, but we assume it's circular. Keep it simple. Now, is M2 an object? Is the satellite an object? Yes. Is the Earth an object? Yes. So what do we know about all objects in the universe? They attract each other, and that's a gravitational force of attraction, right? Okay, now focusing on M2, if we sum the forces for M2, what's the only force acting on M2? The gravitational force, right? What is the sum of the forces always equal? MA. This A is a what? Centripetal, because it's in a circular path, right? So you go, okay, centripetal acceleration is v squared over r. Bam, plug that in there. Now, what's the equation for FG? Big G, which you don't have to memorize. That's the gravitational constant. Don't memorize it. G, M1, M2 over R squared. And then which M is that? M1 or M2? M2, because that's what we're summing the forces for. So this is going to be M2 V squared over R. The M2's cancel. One of the R's cancels. And then you get V equals square root GM1 over R. Now the only tricky thing you got to pay attention to here is R. What is R? From center to center. So notice this, 150 miles, is that going to work? What do you have to do to 150 miles? Convert that to what? Meters. 1 mile is equal to 1,609 meters. Ask anybody who runs track. That's a lot of meters. 1,609 meters. So convert that to meters. But look, that's the radius of the Earth. So here's what you got to do. You got to look in the book. There's a table. So you got to figure out the distance from center to center, from the center of the Earth, from center of the Earth to the center of the satellite. That's the R that gets plugged in. Okay, B, the time required for one complete revolution. Now look, once you have this V for anything in a circular path, what's an equation for velocity? For anything in a circular path, what's the distance for one circle? 2 pi r. What's the time for one circle? The period, which is capital T. What they're asking for in part B is the period. So period will be 2 pi r over v. That's how you get the time for one circle. Okay? All right.